Islam, Islam, Islam is I'm with you.
Welcome back to my devlog series where I'm making an MMO by myself. Last episode was really technical, but we got multiplayer working. So this episode will be all about the visuals. Previously, I recorded all my progress chronologically, but as you've seen from the start, my proof of concept is already finished. So for this one, I'll go through how I got here and talk about my references too. My art background is mostly in pixel art and 2D. So this is my previous project, Mundo, where I drew a bunch of character animations, and for the first time I experimented with a really simple grass shader. The problem with this style is that it's very time consuming to make something that looks good and unique, especially with animations. If I were to have multiple walk directions or different cosmetics, it multiplies the time needed by so much. But when done right, it looks really good and it's the style that I'm most drawn towards. So that brings me to my main inspiration, and that is Tessellator. He uses a 3D low poly scene and renders it like pixel art. Therefore, he can take advantage of the 3D animation and lighting and get a similar effect. I remember seeing this a couple years ago and the visuals were just so striking and memorable that I thought I could never do this in my life. But coming back to it now, there were so many people that were fans of his work that created many resources explaining how it was done. I've probably consumed hours of this niche Tessellator community, so if you've ever made a video even related to it, it probably helped me. Now, I'd never made a game in 3D before, and this needing to be in a browser doesn't help either. But in my research before starting this project, I kept hearing stuff about Web GPU. It basically allows the browser to utilize the computer's GPU, so that you can run more performance-heavy programs on the web. This sounded perfect for my use case, but everything I watched on the topic looks so complicated. Even in the first devlog of this series, I said this. Lastly, this is probably really stupid, but I want to use Web GPU for the rendering using Rust. I was so right in me being stupid, because after spending a whole month going through this tutorial and trying to experiment on my own, I had nothing to show for it. I mean, I did learn a lot about the basics of rendering, but when I didn't have the tutorial holding my hand, I instantly got lost. I had a lot of web-specific trouble, and through troubleshooting, I actually discovered that 3JS, which is a JavaScript library for 3D, had a web GPU renderer, which was perfect for me. I now didn't have to sweat just to draw a triangle, and I could also use TypeScript. It also used a different shading language called TSL, which seemed a lot easier to write, but didn't have too much documentation on it. So that catches us up to 1 week ago, where I basically made all my progress. I started with a spinning cube, and then connected the scene to our ECS we made last episode. How I'm doing this is on the ECS side, I created a renderer component, which has a dirty variable. This basically tells us if we made any changes that are different to what's on the screen. So every frame, I go through each entity that is dirty and take their ID, position, rotation, and model information, and then send that through to our renderer. It's really important that I have these quite separate from each other because now I'm using both TypeScript and Rust. Now on the renderer side, I have a map that tracks the ID in the ECS to the 3D object on the screen. When we receive all that data from before and there's no object connected to that ID, it will create a new model and add that to our map. If the object does exist, we just have to update its current data. At this stage, when I created a player on the Rust side, it would create a cube on the screen. Now the cool thing about using a library instead of from scratch is that there's so many useful tools at my disposal. So for the movement in a 3D world, I need to cast a ray from the camera to the ground to set our move target. I thought this would be really hard, but it was only a couple of lines of code. I'm going to keep the 2D movement that we've been using so far, so I'm only sending the X and Z coordinates to our ECS to process. For the height, I'll just automatically update it to the ground height. Next, I added a camera that smoothly follows the player and changed it to orthogonal, which will help us when it comes to the shaders. The first shader I worked on was pixelating the player and adding edge highlights. I used information from the normal map and the depth map to detect where these outlines are. I want to especially thank John Sports, who had an open source project doing this in 3JS, but they weren't using TSL, so I had to use similar logic and rewrote the rest. I added a hastily made rock, and even with my 2 minutes of 3D modeling experience, it still looked good. Honestly, I was just so happy that I had something working and viewable, which kept me motivated. Next, I wanted to work on the terrain. I implemented a height map texture, which takes a grayscale image, and based on how light an area is, it will make that terrain taller. So after we've changed the coordinates of our ground plane, we can now generate the grass. I want to thank Voyage for telling me about this concept called blue noise sampling, which I use to generate the points evenly on a mesh. This can be used for any mesh, so I'll likely use this in the future for stuff like trees. But for now, we're just generating quads on our terrain mesh and facing them towards the camera, which is called billboarding. Now, quick aside, during the last month I had started watching Shameless, and there was this one simple scene that made an impact on me. It was one of the characters just sitting under a bridge, and I just loved the look of the lighting, shadows, and greenery, especially when that train comes through. This is the exact feel I want, and it came from such a random place. Now for the actual grass, I used this Blender tutorial for its logic, but I had to convert it to TSL, which was quite hard because of the lack of documentation. I also had trouble deciding the shape of the grass because they all seemed a bit too jittery and distracting. So I decided just to keep the squares and added 3 main effects. The first was I changed the color based on how high it was, with the highest being the brightest. Second, I gently swayed the grass, making sure it's not too distracting from afar. And lastly, and most effectively, I generated a wind map with noise to slightly darken the color. So this mimics the grass bending and creating a shadow. Now we're here, and I can safely say that I have the tools and technology I need to make the game that I want. I'll treat all our progress so far as a tech demo for what's possible, and now that we've built all these different puzzle pieces, it's time to put them all together. I showed restraint in telling you my ideas before because I didn't want to make any empty promises. So in the next devlog, I'll be getting all my ideas out and planning how I'll achieve it. If that interests you, you can subscribe, and thanks for watching.